So I have legitimately tried to start this video probably 5 times. I am standing in the classroom on Tuesday, election day, trying to figure out how I'm going to say hi to you guys. And honestly, hi, how's it going? I hope you're enjoying your second day without me. These are the videos that you need to watch in order to be able to do the homework. If you are in Mrs. Palomo's or Mrs. Conrad's class, hi and welcome. And yes, I really am just this obnoxious and annoying and cheerful in class. You can ask all of my kids. They roll their eyes a lot, but it's okay because they know I have fun, and that's really all that matters. So we are talking about hyperbolas today, not hyperbolas, hyper hyperbola. We are going to graph today because graphing is actually, believe it or not, the easiest thing for us to do when we're not here, as far as us, being the teachers and you being the students. You will notice some similarities with ellipses, but you will also notice some differences. Like, for example, major difference right away that I see, I am subtracting my two fractions instead of adding them. So difference one. The second difference that's going to be really, really noticeable is that the numerators in your fractions, they change position. Your x could come first, your y could come first, and that's how you tell whether or not it's horizontal or vertical. Third difference that's going to throw some of you for a loop. A squared is not always the biggest number. It is always the first number in your denominators now, the way we have it set up for you in this particular lovely chart. By the way, all of this, yes, we're going to do all of this, but remember, when we do it, it's not quite as complicated. A couple other things to remember. Oh, sorry, scrolling. C squared equals A squared plus B squared. That is for your foci. Okay, that is to find each focus. This is different than ellipses because ellipses it was A squared minus B squared. But A is still the distance from the center to a vertex, B is still the distance from center to co-vertex, and C is still the distance from center to focus. So those things are still the same as they are in ellipses. If the x is first, then it's horizontal, and your vertices and foci are on a horizontal line, and your graph opens left-right. If y is first, then the hyperbola is vertical. Your vertices and foci are on a vertical line, and the graph opens up and down. All of this is on your note sheet. I'm just reading it for you because I know you miss the sound of my voice. When you are working with a vertical hyperbola, you have to totally watch your center. You will see what I mean when we get through several of these examples. Okay, so this is example 1. There you go. You start the same way you would want to start an ellipse. You figure out if it's vertical or horizontal. Right now, my x shows up first, so it is horizontal, okay, which means when I graph it, it's going to open left, right. My center, again, you just take your numbers right here, and you are going to, again, remember, when you're pulling those numbers out, you want to take the opposite. So it's actually a +3, +1, so your center is actually -3, -1. Your a squared equals 16, which leads us to a equals a4, and we're still going to use that number to count out our vertices. Your b squared equals a 9, and that leads us to b equals 3, and that's the number that counts out our co-vertices. And then our foci, got to pick a new color. When you do this, of course, you're just going to do c squared equals a squared plus b squared. So all I'm going to do is take my 16 and my 9, add them together. I'll get a 25. So my c equals the square root of 25, which is 5. And that's what I'm going to use to count out my foci. Now, you start the way you did with an ellipse. You graph your center, so you go to -3, -1, -3, -1. When you are graphing, remember, you don't have to write the coordinates down on the graph, but you do want to label everything that you graph. So that point is the C for the center, so that then I can go, and if I have to pull the coordinates later, I have everything nice and properly graphed, and it's all there, and all I have to do is read those numbers off my graph. My A is a 4. A counts out the vertices, and this is horizontal. So for me to get each vertex, I have to count left, right. Horizontal, left, right. So I'm going to go from my center like we did with ellipses. 1, 2, 3, 4. I've counted out 4. There is one vertex. I count left from my center, go back to your center. You're always going back to your center. And I count left, 1, 2, 3, 4. for my other vertex. Okay, just like ellipses, you are like there are many things that are similar. My co-vertices, I am counting the opposite direction. So if I counted left, right, I'm now counting up, down. So I go to my center, I count up 1, 2, 3. There's a co-vertex. And I count down from the center 1, 2, 3. There is the other co-vertex. Okay. Now, your ellipse is, of course, for a nice circle, and your each focus had to be inside the ellipse. Here's what kind of happens with the focus for a hyperbola. It's actually going to be on the outside of each vertex. It's still going to be inside your hyperbola, but it will be outside each vertex. Your focus still goes with the vertex, so whatever line you put your vertex on, that's the line that you put your focus on. If I counted left, right to to graph my vertices, I count left, right to graph each focus. So I did count left, right. I now have to count left and right 5. So I'm going to count left first. 1, 2, 3, 4, 5. There is my focus. Notice it is on the outside of the vertex if I'm thinking about that. So then I count to the right, and there's my focus. Okay. I have everything on the graph that I could possibly need right now. The next step is the new step. You need to make a rectangular box. You are going to use the 2 vertices and the 2 co-vertices to make that rectangular box. The easiest thing to do is to just pick a vertex and start. So I'm going to go with the vertex that's on the left, and I'm just going to basically go up and make dashed lines. I'm going to go as far up as the co-vertex is, and then I'm going to make a 90-degree turn, go through the co-vertex, go as far over as the vertex is, make another 90-degree, and drop down. And then once I hit the line where the co-vertex is, heading over. Sometimes I make really good dashed lines, and sometimes I don't. Ugh, those are terrible. But you get the idea. You're making dashed lines to create a rectangle. Now, that rectangle has to have some asymptotes. This is one thing that is very, very different than the ellipse. We didn't have any asymptotes with the ellipse. We have asymptotes with the hyperbolas. Here's how you create those asymptotes. Basically, you count from your center up to like this point up here, the top right corner of your rectangle. I counted up 1, 2, 3, and over 1, 2, 3, 4. From this point in the upper right hand corner, I'm going to count up 1, 2, 3, and over 1, 2, 3, 4. I'm going to make a diagonal line going through there. I'm going to count up 3 and over 4 again, just because I have enough room on this graph. Right, so I'd be up there. And then I go backwards. I have to do the same thing. So I'm going down 3 to the left 4. I'm actually going to run off my graph here. So that can just be kind of sketched and eyeballed. All right, and then I've got one going diagonal, not vertical. From left to right, I'm traveling up. And then I will need one from left to right traveling down. So go back to your center, go to the lower right corner. You went down 3 to the right 4. So there's part of it. And then to get another point, I would go down 3 to the right 4. And keep going. And then go back the opposite direction. Those are your asymptotes. Okay, we have to write the equations of those, and I will write those for you in a second. But right now, we can actually graph our hyperbola, and we said it was horizontal, so it opens left and right. Your hyperbola has to go through each vertex, okay, must go through each vertex, and it cannot cross, that's terribly drawn, sorry about that, cannot cross the asymptote. Okay, so it goes through each vertex, it's opening left and right, cannot cross the asymptotes. Now, asymptotes. You can look on the front page of your notes, and there's that really complicated looking equation that says y minus k equals positive negative b over a times the quantity x minus h, or it's flipped if you're doing a vertical one. Here's really what's happening. You are going to take, for your asymptotes, I'm going to write it right here. I tell you that I'm going to write it right there, and then of course I write it right there. You can see that I'm writing it right there. I don't know why I need to tell you that, but you know I feel I need to talk to you while I'm doing this stuff. So we write y minus whatever our k is. Remember, from our center, this is our h, that is our k, and the k always goes with the y value, the h always goes with the x value. So y minus a negative 1 equals positive, negative. Okay, so everything that I'm writing in black is always going to be there. We're going to need some type of slope, so I'm going to put a fraction bar there. I'm not sure which one I'm going to use just yet, what fraction I'm going to use. And then, of course, I'm going to have x minus, and then I write my h value. So it's a negative 3 right there. So it's always going to be y minus, oh, here, I put that in parentheses, sorry. Always going to be y minus my k value equals plus or minus a fraction times the quantity x minus my h value. That's always, you know how I am about laying that framework and putting down everything that I know and then going back and plugging it in. The only thing that I need is the actual slope. And we can actually just figure that out by counting. Guys, your slope of these asymptotes, you already know. We already counted it out. We went from the center to the upper right-hand corner. So when we went from the center to the upper right-hand corner, we went up 3 and over 4. So up 3 over 4. And then you just make it pretty. I mean, you know how I am. We got to write y plus 1 equals positive, negative 3/4. Oh, that positive negative 3/4 isn't very pretty. And then x plus 3. Okay, so your asymptotes, that's something that's going to be a little bit confusing for you because you don't do it very often. But once you do a few of them, you should be okay. That's one in its entirety. I know this video was kind of long. That's because it was the introductory video. We'll go through the next few at a faster pace. Okay?